Next we discuss problem number 25. Okay. A solution of Fe2 plus is titrated potentiometrically using Ce4 plus solution. Calculate the EMF of the redox electrode thus formed when 50% of Fe2 plus is titrated and 90% of Fe2 plus is titrated. Given for the redox reaction Fe2 plus goes to Fe3 plus, E naught is minus 0.77 volt, and for the reaction Fe2 plus plus Ce4 plus goes to Fe3 plus plus Ce3 plus, Kc is 10 to the 14. Okay. So, during titration, solution is during the titration the redox electrode is A. So, during the titration the redox electrode is a platinum Fe2 plus to Fe3 plus electrode, right. So, its potential EOX, if we say E naught OX minus RT by F, because one electron is being transferred Fe2 to Fe3. So, ln activity of Fe3 plus by activity of Fe2 plus. Now, we can consider as activity equals to concentration. Okay, so assuming activity coefficient we are considering 1 here, activity equals to concentration. So, we can write EOX is E naught OX minus RT by F ln concentration of Fe3 plus by concentration of Fe2 plus. Now, when 50% Fe2 plus is titrated, so okay, first problem is when 50% of Fe2 plus is titrated, so concentration of Fe3 plus will be concentration of Fe2 plus, right, both will be the same, right. So, EOX will be E naught OX, right, because minus RT by F ln 1. So, you get this becomes 0. So, we get E naught OX, okay, and the value is minus 0.77 volt. And the second problem is when 90% Fe2 plus is titrated, then concentration of Fe2 plus by concentration of Fe3 plus will be 10 by 90. So, we get 1 by 9, right. Okay. Or we can write concentration of Fe3 plus by concentration of Fe2 plus is 9, right. Now, we use this expression, we will put those values. Okay. So, at 298 K, temperature, okay, so EOX will be E naught OX minus RT by F gives 0.06 log 9, right. So, we get minus 0.77 minus 0.06 log 9. So, we get minus 0.8026 volt. So, this is the value of EMF when 90% if is titrated, and this is the value of EMF when 50% Fe2 plus is titrated. Next we discuss problem number 26. It says the EMF of the cell at 25 degrees Celsius, glass electrode, buffer solution, calomel electrode was found to be 0.232 volt. When the buffer pH is 2.5, the EMF increased to 0.112 volt when another buffer solution is used. What is the pH of that latter buffer? Okay. So, for the cell, this is again some not a very simple problem. So, for the cell, glass electrode, buffer solution, and then calomel electrode. E cell will be E cell, E calomel minus E glass. Okay, so we can write E calomel minus E naught glass plus RT by F means 0.059, and then you get pH, okay, because log concentration of H plus gives pH. So, this is at 298 K temperature. So, for E glass we are using Nernst equation here. Now, for the first buffer, so this is the value of E cell. Okay. Now, for the first buffer, E cell is 0.0232 volt, right? It is given. So, we write 0.0232 is E calomel minus E glass plus 0.059 times pH is given 2.5, right? 2.5. Okay, this is one equation, right? So, from there actually we can calculate this value, E calomel minus E glass. So, E calomel minus E naught glass. E naught glass will be 0.232 minus 0.059 times 2.5. So, the value will be minus 0.1243 volt. Now, for the second buffer, E cell value is 0.112 volt. Okay. Now, we will again use this expression. So, we write 0.112 volt is E calomel minus E naught glass plus 0.059 pH. Now, E calomel minus E glass we already calculated is minus 0.1243. So, we substitute that here. So, we get 0.112 volt is minus 0.1243 volt plus 0.059 pH. So, pH will be 0.112 plus 0.1243 by 0.059. So, the value of the pH will be 4.005. Therefore, the pH of the second buffer solution is 0.005. 4.005. Problem number 27 says consider the electrochemical concentration cell with liquid junction. Okay, so again liquid junction is here. So PT KCl concentration C1 is 0.01 molar, KCl again concentration is different here, C2 is 0.01 molar. Again platinum, the two KCl solutions of different concentration are separated by a liquid junction. Given that the transport number of Cl minus is 0.51, calculate the liquid junction potential ELJ developed across the junction at 25 degrees Celsius or 298 K temperature. So here T minus, value of T minus is given, so T minus is 0.51, right, the transport number of Cl minus. Okay, so T minus is the transport number of Cl minus. Of Cl minus ion. It is given. Okay, we know that ELJ or ELJP, liquid junction potential, we can write ELJP here. Okay, ELJP means liquid junction, the EMF of liquid junction potential of liquid junction potential ELJP is 2T minus minus 1 times RT by F ln C2 by C1. Okay, that we discussed in the class. Okay, so now we substitute all the values. So 2 value of T minus is 0.51 minus 1 and RT by F and then 2.303 if we multiply we get 0.06 log concentration of C2 is 0.1 by 0.01. So we get 0.02 times 0.06. So we get 0.0012 volt, or you can write 1.2 millivolt. Okay, this is the liquid junction potential ELJP. So we substituted RT by F times 2.303 because the temperature is given 25 degrees Celsius. Okay, so ELJP. So the value of the EMF of liquid junction potential is 1.2 millivolt. Problem number 28, it says consider the cell reaction at 25 degrees Celsius, Ag, AgCl, HCl, again concentration cell. HCl is 0.1 molar, AgCl, Ag, the transport number of Cl minus again T minus is 0.6, calculate the total EMF of the cell. So here the transport number of Cl minus here of Cl minus ion is T minus is 0.6, right. So again it is a concentration cell because concentrations of HCl are different. Okay, so it is a concentration cell with transference. We already discussed this thing in the class. The overall reaction can be written as T minus H plus 0.1 molar plus T minus Cl minus 0.1 molar is in equilibrium with T minus H plus 0.01 molar plus T minus Cl minus 0.01 molar, right. This is the overall reaction. Therefore, E cell is 2T minus RT by F ln C2 by C1. So, we write C2 here is 0.1 molar. So, C2 is 0.1 molar and C1 is 0.01 molar. So, T is 25 degrees Celsius, means 298 K. Okay. So, these are the value given. Okay. So, E cell will be T minus is given 2 times 0.6. Now, RT by F and 2.303 is multiply at 298 K, we get 0.06. Okay. And then log concentration of C2 is 0.1 by 0.01. So, you get E cell is 2 times 0.16 gives 2 to 0.6 gives 1.2 times 0.06 times log, and this is 10. So, log 10 is 1. So, we get E cell, value of E cell is 0.072 like this. Okay. Now, we need to also calculate ELJP, right, liquid junction potential. Okay. Again, the EMF of liquid junction potential if we say ELJP is twice T minus minus 1 times 2.303 RT by F log 0.1 by 0.01. So, if we calculate this, so 2 times 0.6 minus 1 times, so this value gives 0.06 times log 10 is 1 again. Okay. So, we get 0.012 volt. Okay. So, this is the liquid junction potential, that is the cell potential. Okay. So, we need to add them. Okay. Total EMF. Therefore, the total EMF of the cell so, we had to calculate E cell and ELJP separately here, and then we need to add them. The total EMF of the cell is, we write E total is E cell plus ELJP. So, value of E cell we calculated 0.072 and the value of ELJP also we calculated ELJP is 0.012. So, you get 0.084 volt. So, this is the value of total EMF of the cell or E total. Now, next we discuss problem number 29. It says for the cell reaction Zn2 plus Cu2 plus Cu, how will the cell potential change if the concentration of Cu2 plus ion is increased. Okay. First, we need to consider total cell reaction. Okay. So, overall cell reaction is the overall cell reaction is, so Zn is getting oxidized. So, Zn gives to Zn2 plus, Zn solid gives Zn2 plus aqueous. This is happening in anode, and in cathode Cu2 plus aqueous is getting reduced to Cu solid, right. Here N is 2. n is 2, number of electrons involved is 2 here. Okay. So, from Nernst equation, you can write E cell will be E naught cell minus minus 0.06 by 2 log concentration of Zn2 plus by concentration of Cu2 plus at 298 K. So, this is the expression we need to consider. Now, how will the cell potential will change, E cell change if the concentration of Cu2 plus ion increase. So, if Cu2 plus ion is increased, so denominator it is getting increased, right. So, overall this value will decrease, right, and you have the minus sign. So, E naught cell but the value of will increase, E cell will increase here, right. So, that what I said is, so if concentration of Cu2 plus is increased, then log Zn2 plus by Cu2 plus it will decrease. Right. Okay. So, it will decrease means, okay, again log of smaller number is more negative, right, more negative. So, this makes the E cell value increases, okay, increases. So, A is the correct answer, A is the correct answer. So, number 30 says, for a redox reaction with delta is greater than 0, increasing the temperature will generally increase electrode potential, decrease electrode potential, does not affect the electrode potential, this reverse the reaction. Okay. So, which one will be the correct option? Okay, let us see. Okay. So, we know delta G naught, we know delta G naught is minus NF E naught cell, right. So, we can write E naught cell is minus delta G naught by NF, right, or we can write delta E cell will be minus delta G by NF, right. N and F both positive quantities, right. Now, again delta G is delta H minus T delta S, right. So, if we substitute this here, we get E cell will be minus delta H by NF and we get plus T delta S by NF, right. So, if we increase temperature, okay, again I said that, okay, so when delta S is greater than 0, then increasing temperature will make ECl higher, right, or it says that increase in, or in other words, increase in electrode potential. So, option A is the correct option.